Good evening, all. Life is wonderful, but it's full of challenges and struggles as well. And sometimes all you just need is a bit of motivation, and here it is. So, we are much delighted to welcome you all to the first episode of iTalks. With great pleasure, I would like to welcome today's speaker, Dr. Valsa B., scientist and former director of System Reliability Entity in Vikram Sarabhai Space Center. She was the first lady quality chief among all the ISRO senders, as well as the first lady deputy director of systems reliability in VSSC. She's here to share her experiences with us, and warm welcome to you, ma'am.
Okay, thank you. Shall I start?
Yes, ma'am.
Can you just give me a brief about your community, this EITY, whatever it is? What does it do? What is the objective of this group?
Actually, this community has been started by a bunch of students
Yes.
for conducting different events related to technology, entrepreneurships, and workshops are being conducted. Till now, we are conducting online webinars and all for the
Okay.
different college students.
So the kind of audience will be third year or fifth year or which set of
Uh,
students will be attending this?
Mainly college, engineering college students of all years.
Okay. 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 So good evening to all of you, and thank you for giving this opportunity. So shall we go to my presentation?
Yes, ma'am.
Oh, sorry. Something happened. Okay,
Nothing.
something happened 1 minute. Okay. Okay, you can see my presentation now. Okay, so
Yes,
this
ma'am.
is called, I'm giving a very short trip through challenges and opportunities in Indian space research. So basically, it will be about what ISRO is about, the origin of ISRO, like a brief overview of this will be. That is brief introduction to origin of ISRO. I'm sure you all know ISRO stands for Indian Space Research Organization. And ISRO activities are launch vehicles and satellites with short introduction and satellite application. Then launch vehicle design elements. Okay, and how I ended space research because I was also a student like you, and then that time I never had any idea that I'll be working in this organization. Am I audible? Hello?
Yes, ma'am. Yes.
Yeah, because I cannot see you when I'm presenting. I don't know whether you all are hearing me. If at any point of time you cannot hear me or see my presentation, please interrupt, okay? And then opportunities and challenges for engineers in space. This is how I have organized it. So one thing I want to tell you, I think satellites is there in your life right from the time you wake up till you go to sleep. All the things, the news, the TV channel, your mobile activities, or be whatever it is, or net banking, or online shopping, everything is done with the aid of satellites. So satellites has become an inevitable part of uh, our life. And ISRO plays a major role in putting these satellites into orbit using our own launch vehicle. That is the most important part. We were using satellites which were launched by earlier by Russian launch vehicles and ESA launch vehicles, but we are now launching satellites using our own launch vehicles. So Vikram Sarabhai Space Center makes the launch vehicles, and we have a unit in Bangalore called URSC, UR Rao Space Center, Research Center, which makes the satellites. And then we have a satellite application center in Ahmedabad, which will be giving the application part, all the payloads. Payloads is the useful part of the satellite, which is used for getting all the data and using it. So there is the other part, the structure and other things which is required, the battery and all that, that will be made by the URSC Bangalore. The application part, the cameras or the transponders and all those things will be made by the Space Application Center, Ahmedabad. And then we have Sriharikota from where we launch. These are brief are the four main centers. Then we have the National Remote Sensing Center in Hyderabad, which will be disseminating this data to the general public, whoever wants to use it, like meteorology or mining or finding water resources, all those things. So these are the five major centers which we have. We have a lot of other centers which I'm not touching. So I'll go to this next one, like October 4th, 1957. Actually, it is the dawn of the space era. The Sputnik 1, the first man-made Earth satellite, was launched by the former USSR, and it opened the way for space exploration. Actually, October 4th to that week following that, 1 week from October 4th is celebrated all over the world as the Space Week. When by that Space Week, we also celebrate in ISRO VSSC. And that's the time when our space museum is open to general public, and all the schools and other places come, and every day we'll have a launch of the sounding rocket. With that, because from Trandrum, we can launch only small rockets. We cannot launch the big rockets like PSLV, GSLV, or GSLV Mark III. So this is considered to be the dawn of the space era. And why Vikram Sarabhai Space Center or ISRO came to Kerala is because the Earth's magnetic equator passes near to Tumba, a fishing hamlet near Thiruvananthapuram. And Vikram Sarabhai, who was the founder of that, he was basically a physicist, and he was interested in studying about the atmosphere. So that is what these sounding rockets are used for. And he came here, and there was the church, the Saint Mary Magdalene Church, which now serves as the Space Museum. At the time, that was used as the laboratories, and the bishop's house, which was nearby, was used as the office. So now it is converted to Space Museum. So the sounding rockets first, the Nike Apache, that was from US. The first sounding rocket launched from Tumba was in 21st November 1963. So nearly 60 years before. And then Rohini 75, that is Indian sounding rocket, which was launched from Tumba in 67. And you can imagine the weight, it was only 10 kg. Now the weight of our PSLV, GSLV are in tons, okay? So you can see the sea coast. At that time, these rockets were so small, they were being taken in cycles. And you see how they are sitting and assembling like fireworks. They're just, actually, this is Kadam, who's sitting on the right, and the left is Dr. Arvamudan, who used to be the Deputy Director of Systems Reliability, and then later on became the Director of Sriharikota and Bangalore Center. See, they're taking it in the cycle. And the operational launch vehicles are the mainly PSLV, GSLV. So it is capable of putting in lower orbit 3.5 tons, in sun synchronous polar orbit 1.6 ton, and in GTO 1 ton. Actually, this is the main workhorse. So far, we have had 56 launches, and recently also we had launch of PSLV C-54. Before the continuation flight, C stands for continuation flight. Before that, we had 3 launches which are called as D1, D2, D3, developmental flights. And the Chandrayaan 1 was launched by PSLV. The Mars Orbiter mission was launched by PSLV. And we have had a record of 104 satellites which was launched by PSLV C-37. Then we have the GSLV, for which can put in a lower orbit for 4.5 ton, and SSPO 2.2 ton, and GTO 2 ton. And we have Mark III, which has been now declared operational, which can put 4 ton class of satellite into GTO, geostationary transmit orbit. So these are the main launch vehicles which we have, PSLV, and Mark III. And you can see our spaceport, which is at Satish Dhawan Space Center, which is at Sriharikota. This is, you can see the map, it's in the Telangana district, Telangana state. And it is towards the east, we can launch. See, but the thing is, Earth moves from west to east. So it will aid the rocket to travel more. That is why we always prefer an eastward launch. Now, some pictures you can see. This we see in this is all done in vehicle assembly bay in Sriharikota. We have huge cranes which is lowering the first stage into the launch pedestal. This is the launch pedestal. It is being lowered very carefully, and you can see the human beings standing there like small dots. They are there to guide it so that it comes and lands properly. It will be very slowly. It will be moved because we cannot afford, because this is the first stage of PSLV is a solid water. If by any chance some mishap happens, it can explode on that site itself because the solid propellant is packed. In liquid stage, the liquid will be filled only after it is assembled. So there is no such danger in lowering as liquid stage. So the first, the solid stage is there. Actually, for the PSLV, the first stage is solid, and the third stage, it is a four-stage vehicle, and it is about 44 meters tall. And the first stage is solid, the second stage is liquid. Again, the third stage is solid, and the fourth stage is liquid. That is the configuration. And the different stages are being stacked. This is just to give a visual idea of how the launch vehicle is being handled. And it is like stacking a cake, but not a cakewalk. This is something which we have to keep because it is a highly ultra precision work which has to be done, and it is be done very carefully, and it is very risky job also. So this is something about the launch vehicles. Now I'll say something about the satellites, which we have made. These are the early satellites to give you an idea. Aryabhatta, which was in 1975, then Bhaskara in 1979, Bhaskara 2 in 81, 1980 Rohini, and Rohini, RSQ, SROS-C, Apple. Then we have IRS, Indian Remote Sensing Satellite, and INSAT, which is our communication satellites. Now, recently, which we have launched is an EOS, Earth Observation Satellite, which is for observing about the characteristics on the surface of the Earth. Like that, we have so many satellites. The number is very large, and we are using it for multi-purposes. Like I'll be talking about it when we come to the application part. So this is the application, where space application we can see. See, telecommunication. As you all naturally know, telecommunication is the major area. Then TV broadcasting and search and rescue. This is one thing. We have made a beacon which can be used by fishermen so that when they go fishing, if they get lost, they can send a distress signal immediately. The Coast Guard can go and help them or send a helicopter to rescue them. Then radio networking, then satellite news gathering and dissemination, and of course meteorological application. Actually, earlier days, I don't know whether you all know about it, but in my younger days, when there used to be storms and cyclones and all that, lot of people used to die. Actually, in the Odisha shore and in the Andhra shore, hundreds of people used to die because there was no warning and people were there and they were killed. But now what happens is, because of these good data which we get from the satellites, we are able to warn them very much in advance. Actually, the casualties reduced to one or two, and that too because the people don't move out. It is not because of lack of knowledge; they believe it will not happen, and that is how it happens. That is why the cyclone warning services is very much useful. The meteorological services are there. Then, other than that, the remote sensing data is used to find out the number of like rhinoceros in Assam forest and all that. They keep track using the satellites. Then forest fire you can know. Then if a locust, that is which will destroy the crop, is going to come, they can be warned. And then water, where water is available, instead of simply digging somewhere, we can know where water is there. And fishing zones, people need not go just where some random places, because by accurate satellite images we can know where the fishes are available. Actually, in Vizhinjam, in Trivandrum also, there is one place which will give them guidance in which direction the fishermen have to go to get a good catch. So like that, there is a satellite imagery application is there in every walk of our life. Then telemedicine. Telemedicine is a very popular thing, and it is actually I think now more hospitals are connected. 384 hospitals were connected to 306 remote district hospitals because, see, all the specialists are there sitting in the city, and in rural area they cannot get the benefit unless they travel to the city. So this telemedicine initiative has been taken up, and actually a lot of specialists come a panel, and the doctors in the rural area along with the patients can discuss with this doctors and find a solution for their problems. So that is one area which is widely used. And you all must have heard of Google Maps, but we also have a Bhuvan, gateway to geospatial world. Actually, so many details you can get. Actually, this is the address: http bhuvan.nrc.gov.in. Please take some time to go and visit the site and see what all you can get about India. It is covering only India. We are not giving the world, but Indian details are there. So quick, this is the space transportation system which we have now. This is a PSLV, this is the GSLV, and this is the GSLV Mark III. We call it LVM3. Now these are the next way forward. That is SSLV, that is Small Satellite Launch Vehicle. Actually, this is a very, you can put a 200 kg satellite in orbit of some 300 kilometers. And mainly it is required for defense applications. Suppose we have some insurgency or some threat, and we want to monitor whether there are foreign soldiers moving into our area. This can be taken. It can be taken in a small launcher and launched from there. That satellite can be launched, so we can monitor very easily these movements. And it's only for a short duration, maybe for 45 days or something like that. So that is the reason for the small satellites launch vehicle. Then Mark III is going to be modified. This at the top is the crew module where the crew will be sitting, and it will be used for our Gaganyaan, that is the human space program, where man will be sent into the man or woman will be sent into the space. And then, okay, we have other things with orbital reusable launch vehicles, then heavy lift launch vehicles. These are all where R&D, that is research and development activities are happening. This Gaganyaan is supposed to be, we had one launch of SSLV, there was a minor error, so that was not a complete success. And Gaganyaan is supposed to be launched in 24. Unmanned, we'll have 2 unmanned launches, and then we'll have a manned launch. Okay, small satellite, I have told this launch on demand. In 3 days, it will be possible to launch this satellite from this. Then major ISRO missions, I'll just give you a quick glimpse. One is, as I told you, PSLV is the versatile. It is called the workhorse of ISRO. It has reached all destinations in space. As I told you, 56 missions, 4 variants, multiple orbits, multiple satellites, and lunar, that is around the moon, as well as planetary, that Mars orbiter mission. Mangalyaan was also done using PSLV. And we have done some experimental also. The last stage, the 4th stage, has been used as an orbital platform, and some experiments have done. And typical satellites which have been used are listed: Cartosat, Astrosat, IRNSS, METSAT, SRE, Mars Orbiter Mission. And then 104 satellites also from PSLV 37. We made a world record. And you can see the commercial launches, we have launched around 345 satellites, and 36 countries have used our services. And to get some idea of the components, the electronic components in a PSLV launch vehicle, there are something like 75,000. And lakhs of nuts and bolts, which is holding all the different stages or the different, as I told you, first stage, second stage, third stage, and fourth stage. And around some 55 kilometers to 60 kilometers of wire interconnecting all the different stages and the electronic packages. Actually, all the electronics packages are situated at the top, because once the first stage is burned out, it will be left out, because we never carry the dead weight. It will be ejected, and it will be designed in such a way that it falls into the sea or in uninhabited area. Then PS2 will eject, and PS2 will take the vehicle further like that. So the master, the brain of the launch vehicle is in the equipment bay, which is in the 4th stage of the launch vehicle. And that is where the brain, we call it. So till the end, it will be available. So PSLV is the versatile vehicle, and the space capsule recovery experiment was done using that. This is the first step which we did actually some nearly some 20 years back. We did this because we wanted to check our capability to have a crew module which can take human beings and then reorient and deboost and let safely land in the sea, and it is recovered. And if you visit the Space Museum, I don't know whether any of you all have visited the Space Museum, you will see the recovered space capsule module is there. You can see that it is something which used to amaze us because this is something which has gone to the space and have come back and is safely available. And Chandrayaan 1, which was also launched using PSLV, a lot of payloads. What I told you, whatever the moon impact probe or the SARA, solar wind monitoring, the high energy X-ray spectrometer, these are all called payloads. These are the different things that is assembled on it, which will be doing different functionalities. And actually, it had done a brilliant job, and we found that water was present in moon. Though earlier people had no idea about it, our experiment, Chase was able to find out that there was water in the moon. And the Mars orbiter mission, which is called MOM, it was the first interplanetary mission. And the objective was to understand the surface feature of Mars, like morphology, topology, and mineralogy, study the dynamics of the upper atmosphere of Mars, effects of solar wind, radiation, and escape. It is called the red planet, you know that now. And it was inserted into an orbit 423 kilometer by 80,000 kilometer, and it was we are the first nation to succeed in first attempt. So we hold a record in that first in Asia and third in the world to go around Mars. Sorry, and it was expected to have only a life of 6 months. But what has happened is even now we are getting data. So even after so many years, nearly 8 years, we are still getting data from the Mars orbiter mission. And these are some of the pictures which we have got from that. So this is the way forward, or this is the vision of ISRO. That is self-reliance in space transportation and space application and societal services, because this is something which our founder, Dr. Vikram Sarabhai, has told. Space research should be used for the benefit of common man. Only then we'll reach it. As everyone will ask, why India is a poor country, why we have to need it. But we need self-reliance in space transportation, because we don't have to depend on other countries to launch our satellites. And at the same time, we should have some services, because I told you, we are doing a lot of services. In fact, there was a meeting some years back, like 2016-17, when the PM had called. The current PM was the PM then also. He had called for a meeting of all the secretaries of different departments, and they had to say how the satellites can be applied in the different field. So roadways secretary was saying how they can plan the roads effectively because of the satellite imagery. And the postal division secretary was saying how it can be used for speedy transfer of parcels and other letters. So like that, everyone was saying how it can be done. So the space between the common man and space should be less. That was the motto of the PM at that time. And this is what we are trying to do, and that is what this is being done, and is being successful also. And some question that commonly asked, why manned mission? India is a poor country, why we have to have manned mission? But space colonization is going to be a reality. In fact, I've been fortunate to hear Elon Musk speak once, and he wants to start a colony in Mars in 2024. So when other countries are racing for that, or for other minerals and all that, we should also not be left behind. We are one of the 6 space-faring countries in the world. So when we should also know what is happening, and we do it in a very cost-effective way. We do it very cheap. In fact, the cost of our Mars orbiter mission was less than the film Gravity. What money spent on making the film Gravity? That is what was told. And in fact, the mileage was also, somebody was saying the amount of money we have to spend per kilometer travel is less than what you spend in an auto. So we do it in a very cost-effective way, so that we can have. So, and another thing is, all our launches have caught the imagination of all the people. One thing, can you hear me? Are you all with me?
Yes, ma'am.
Yes, okay. Because I am keeping on talking. I'm not seeing you. I'm not getting any response. So I just wanted to know. So that is why we are going in for manned program. And if humans are to live for a long periods with the intention of extended settlement on another planetary surface, it is likely to be on Mars. That is what people are thinking. And we are also going in a small way for that. And there are many spin-offs from space research. Actually, so far, around 300 technologies developed by ISRO has been transferred to Indian industries, and a few of them are distress alert transmitter, what I told you, the fishermen can use. Artificial polyurethane food. This is very lightweight. In fact, it is that is a picture you can see. The other artificial limbs and all are very heavy. This is very light. You can have a feel of it if you go to the space museum. Then fire extinguishing powders, uh, automatic weather station, silica cloth which will not catch fire, then slip rings, agrophotometer, pet clean, lot of things we have given to the industries, and this is being used. So whatever technology we use or the research and development we use, the spin-offs from that is used for the benefit of the society also. So then space technology, what is so special about space technology that it is different from other technologies like IT or motor or automation and everything? It is complex. See, something, there's a saying, and somebody is taking a long time over doing something. Come on, it is not rocket technology. That is a standard usage. So it is assumed that rocket technology is very complex and it is state of the art, and high degrees of accuracy and precision is required. And space is very unforgiving because a small deviation or bug in even one of the thousands of lakhs of elements, subsystems or software can cause a catastrophic mission failure. In fact, our first PSLV D1 failure was due to a software error. It was due to an overflow. We were using a Motorola 68,000 microprocessor, and we were using fixed point arithmetic, and there was a deviation in the launch vehicle, but where what happened is the velocity grew greater than what can be represented by the computer, and it resulted in overflow. So what we should have done is we should have clamped at the highest value that is possible to be represented and gone ahead. But that was missed. One flag was checking was missed, and that resulted in a failure. So that is why we say it is very unforgiving, and the thousands of crores of rupees will be gone into the sea. So quality and reliability play a very crucial role in the success of ISRO missions. And I was heading the quality and reliability group in launch vehicle area. And I'll give you a brief introduction to how a launch vehicle design happens. The first part is the aerodynamics, the thermal studies. They design the configuration. Like I told you, PSLV is a four-stage vehicle. Number of stages, whether it has to be solid or liquid, or whether there has to be strap-ons, things like that. They study. In fact, our aerodynamics people are studying for launch vehicles which will be launched 10 years later. So they are doing the studies now, and how the thermal management. Thermal management is a very important area because the heat that happens when the vehicle goes through the atmosphere is very intense, and how to manage it is a study by itself. And at the time when they decide the configuration, the structures and the materials people. So they choose the material of the, we call this stage motor, rocket motor, the materials for the motor, the structural design, analysis, testing, and whether it can withstand the pressure or the intense heat that can happen. The structures and materials people come. At the same time, when the propulsion has been decided that solid, liquid, or cryogenic, those people do the studies to meet the requirements of the configuration, which has been first finalized and studied by, they make small models, they do internal testing and see whether their model will really work in an atmosphere. And those people work on the propulsions and the structures and materials. And next comes, I told you that the brain of the launch vehicle is in the equipment bay. This is the navigation, guidance, and control. This is highly software intensive, and it is depending on a microprocessor. Actually, ISRO has been using our own developed Vikram processor, which is a 16-bit processor and which has got its own compiler, its own assembler, linker, everything indigenous. Because there was a time when America refused to give us microprocessors. So at that point of time, though we managed to survive by stockpiling a number of microprocessors, we felt that no country should be able to dictate to us. So because they could put a stop to our launch vehicle program, we started developing. And that started in the early 90s, and 2008 onwards, we have been using our own processor for our navigation, guidance, and control. Navigation says where you are, and guidance is where you want to go. And control reduces the gap between where you are and where you want to go. So there will be a control system, closed loop control system, which will take us to where we want to go. And these are vehicle avionics. To give you a picture, these are some of the structures in the launch vehicle on which the avionics, the space electronics is called avionics. Avionics packages are mounted. And all these things are done by the integration and checkout, the mechanical part as well as the electronics part, integration and checkout people do. And all these stage auxiliary systems are there in between. Stage auxiliary means which system, it only gives the ignition command. When the navigation control guidance system computer gives the ignition command, this gives the pyro systems which will ignite it. So they play a very crucial role. If when the command comes, if the system does not ignite, the whole mission will be lost. So everything, all disciplines work together to realize a successful rocket. So now, what is it in for you all, engineers in space? Because all of you are engineers. So I say ISRO is an ocean of opportunities, because there are in VSSC we have around 4,500 engineers uh, staff. Out of that, 3,900 are engineers. The rest are administrative people, and a little bit of them are IT and diploma people, but majority of the people are engineers. And almost all branches in engineering, mechanical, aeronautics, chemical, electronics and communication, structural engineering, with a sprinkling of civil and electrical. Electrical and civil people are less, because civil people are required for our structures, and electrical people as such we don't take. When they do specialization in navigation, guidance and control, there is a stream in a CET, I think, for MTech. If they do that, they are absorbed there. And basic sciences like mathematics, applied mathematics is very much used to find out our orbits, and whether when we are traveling, whether any debris is unwanted material from the used satellites and space dead satellites, whether it will come and hit us. Then physics is there, and they come up with a lot of experiments. Chemistry people are there; they also do a lot of R&D. They are also required in space research. So that is why I say all, because it is a multidisciplinary system. All branches of electronics, I mean engineering and science, basic sciences are used in. There are people, scientists also, as well as engineers working in ISRO. And engineers, see, one thing is no gender discrimination at recruitment, merit is the only criteria. And one thing which I have observed is, I have been in a number of recruitment committees. Majority of the people who have appeared for the interview are from North India, and in southern states, Andhra and Tamil Nadu. But Kerala, very few people come, I think, because the kind of admiration and interest shown by the students in the northern states and in Tamil Nadu and Andhra is very high, because they want to get into ISRO. That is the feeling. But I don't know whether that sort of enthusiasm is there among the Keralites. That must be the only reason, because merit-wise, they are no way behind in any other state. But the people who come for writing the test and who clear it and come for the interview, the Keralites are very few. I found that. So please have this fire in you that you want to get into it, because this is something which is of national importance. See, one thing when you work in an organization like ISRO is you feel a pride, you feel an ownership, you feel you are being observed as a whole nation, and whatever you do is being seen by the entire nation, and they uh, appreciate it, and when they have rejoice along with your success and cry along with your failures. So that kind of spirit should be there. So, and the career is challenging and with opportunities and new development and innovations. We don't require, we require not only engineers for research and development, we require engineers for testing, we require engineers for integration and for testing out the launch vehicle, quality and reliability. All arena of the engineering is there for you to work. So it is challenging with opportunities in development and innovations. And work demands precision and excellence, and hence there are work pressures to meet schedules and overall objectives, because you make a mistake, it is unforgiving. There is no opportunity to correct. So, first time right and every time right. That is the motto we have to follow. Because unlike in an IT or even in an automation, you can have some scope for correction. But here, once the launch is taken off and you have made a mistake, that will result in a failure. That's all. So, precision and excellence is a must. So some of the traits required in a space engineer, technical competence. There is no compromise on competence. You have to be competent in your field of specialization, and you should be up to date with what happens in the world. And I think this is true for any field which you go. You should be competent in your area, like even if it is IT or you are going into some core industry area, you should be competent. Then training. See, you should know we all don't come with all competence. So you should know which are the area you'd like to get trained. Identify your field of weakness and try to get training. And the organization all actually in 10% of our annual budget is set aside for training and sending people to seminars, conference, and training them by inviting experts and all that. Then communication. Communication is very important. When I mean communication, you should be able to communicate to your people, that is top or bottom. As you grow up, you'll have people beneath you as well as bosses above you. So you should have a vertical line of communication and horizontal among peers. Peers means people who are equal to you, so that you know what is happening in your area. In the PSLV, now what is happening, what is if there is a problem there, whether it has an impact on your system. So that way, communication is very important, and you should have communication among all the top people as well as the peers as well as the bottom people. Then decision making. When you hear something or when you have a problem, you should be able to make a decision whether to go ahead or rectify it and go ahead. So the capability of making decision is very important. For that, you don't have to do it alone. You can always write the pros and cons and you can discuss with people. When I say decision making, don't make a decision on your own. Always make the decision and you should be able to justify why you are making it, and you take it to your boss and convince him. And if he's not convinced, and if he says there's a problem, go back and see into it. So decision making is something which you have to do. Then be a member of professional societies. This is a big platform where you can meet professionals working in similar area, and that is when you get ideas of what is happening elsewhere. So professional societies help you in attending conferences, seminars, and you get to meet different people in different areas of working, and you interact with them, and your knowledge improves. And managing multiple roles, especially for the ladies, because once you become a career lady and you get married, you have to do, there should be a work-life balance. Even for men, it is there. Both have to be able to do multiple roles with proper time management and proper assessment of responsibilities that should be done. Otherwise, you'll be heavily stressed. And you should have some recreation also, which is all work and no play makes Jack a dull boy or Jill a dull girl. So you should have some recreation also, but you should have a proper work-life balance also. Now, how I entered space engineering when I was in school, and even in college, I never thought I'd become, because, like, I studied in Holy Angels Convent and I did my pre-degree in women's college. And I took this group. I thought I'll go for engineering, and I wanted to go for ECE and did that. But I never imagined that I will be going into space research or anything. I just wanted a job. But when I was young, that was in the late 60s and early 70s, every Wednesday there used to be a launch from Tumba. And at 5 p.m., that launch will be there, and we can hear it used to be a two-stage rocket. So I used to run to the terrace to watch it, and sometimes I'll be seeing the fire also, each stage ignited. Otherwise, you will just see the trail, a cloud of the exhaust coming. And I used to watch it, and it must have made an impression because though consciously I had not made any decisions, I had my internship during college days at VSSC, and I saw the vast amount of, because that was a very intensive package. 4 weeks I did. I was taken to electronics lab with the mechanical integration. I was taken to see a rocket launch of the sounding rocket. And I saw it and I thought I saw the way the people were working as a team. The strength of ISRO is teamwork and reviews because everything you make is reviewed thoroughly and everyone works as a team. There are no heroes or villains. It is team. And I was very appreciative. So, though initially I joined Calpron to Antrim, when I interviewed for call appearing in ISRO VSSC came, I attended and I got, and I was given a lot of challenging jobs. And I can tell you that at the time when I joined, I never thought I'll become the deputy director. I just joined as a scientist engineer SB, or at that time SB was there, SC, and then DEF, like that it goes up, and I retired as outstanding engineer. Now, why I'm telling you all this is, see, you people can also do it. See, dear student, don't think anything is unobtainable. Everyone can achieve everything if you set a mind. But you should be hardworking. You should be paying attention to details, and you should be meticulous in whatever you do. The traits which I told you, which you have to do, if you have it, you can be successful as a space engineer or a space scientist. And Kalam, an inspiration forever. We are all born with a divine fire in us. Our effort should be to give wings to this fire and fill the world with glow of its goodness. He's an inspiration for our, and you all should take uh, inspiration from his words and try to fulfill your wishes. And I'm coming to my conclusion because 45 minutes was what I was told. So space research is a very challenging field in science and technology, which is still male dominated. Actually, the percentage of women to men in VSSC is 78, 80% to 20. It is 80% males and 20% women. And the top levels, that the level which I occupied, there was less than 10% as women. So take it as a challenge, girls, and please join ISRO and make it more balanced. So one thing, finally, I can sum it up. Use the following to succeed. Be technically competent, excel in whatever you do. Do not be discouraged by any discrimination because, see, don't expect a rosy path. Every path is filled with stones and thorns. It is not a rosy path. So if you come across some discrimination or some discouragement, keep doing your job. And ultimately, you will be recognized and appreciated. If you do a good job, nobody can ignore you. Please keep that in mind. If your job is well and if you are exceptionally good at doing it, even if somebody wants to put you down, that will never happen. Then be open and willing to embrace challenges and explore fresh avenues. See, this is something which I have found with some of my youngsters. Some people are very enthusiastic. You give them any tough job, they'll say, give me more. That is, some people, even though they're capable of it, അയ്യോ മാഡം എനിക്കിത് ചെയ്യാൻ പറ്റില്ല. That is the first response. എന്നെ കൊണ്ട് പറ്റുമോ എന്ന് അറിയത്തില്ല. Don't take like that. You take the challenge. It is not that you're doing it alone. You have faced a problem. You can go to your seniors. You can talk to your peers. You can come across, discuss, and find out a solution. So always be willing to embrace challenges and explore fresh avenues. Then cultivate and stay in touch with professionals and friends in your field. Please have a networking because now with WhatsApp and what Instagram and what all the social media, it's possible to stay in touch with all your friends across the globe in the country, and you can be up to date with what is happening. Then be proud to be a space scientist or engineer, and instead of sky, space is the limit. Even I would say even outer space is there because deep space and outer space are the areas of interest that's going on because some of the forthcoming missions are in Aditya, which is about sun exploration. Then Venus, Shukrayan is there. Then Mars orbital mission 2 is there. Then Chandrayaan 3 is coming up. Like that, everything is in the outer space. So if you become a space engineer, a scientist, instead of sky, space is the limit. So thank you.
So we have reached the end of the session. So if you guys have any doubts, please put it up in the chat box.
Any, any question? Or you can ask also if you have, if you want any clarity on anything.
Ma'am, how feasible would be space travel in the future? Would it be like the US space programs in the past, or would it be more, you know, longer?
Okay. Our space program or our space travel, what is being planned in Gaganyaan, is only for a short 3 days, and it will be in a low Earth orbit, and they will be going around the Earth. And the crew module, actually, if you go to the space museum, you can see it's very congested. It is very small. You don't have much space to move around. You just can lie down like this and maybe sit up a little bit. And it won't be very comfortable. Don't expect like that in Gaganyaan. And maybe Elon Musk's and all that, what they will have might be more, because space tourism, when they want to do it, the creature comfort has to be taken. But whatever ISRO has planned is not too comfortable, but it will be reasonably okay. But it will be just initial stages to study how you can go around and see how comfortably you can travel and then come back safely. That is the main objective. Later on, the creature comforts and things like that can happen.
Ma'am, in that regard, it would be mostly for research purposes, right?
Yes, yes. Not
Okay.
for space tourism. We don't have the luxury for space tourism. It will be for R&D purposes, and then later on, if possible, maybe we'll go to land in Moon or Mars later on. But it will be, we are now in the baby step stage only. We cannot think of that high end on that. First, we have to take a crew into outer space and bring them back safely, and then we can think about further.
Okay, ma'am. Next question would be, if it would,
Somebody,
continue.
1 minute. I think somebody has asked a question when we'll have a space station. We will not have an individual, at least now we are not planning to have an individual space station for India alone. Yeah, International Space Station was a joint effort by a number of countries. We might become a part of that, but so far we have not thought in that line. If any Asian countries join together and set up a station, we might become part of that, but that is not in our priority. And our internships are open to fourth year undergrads if face. What are the procedure and requisites for the same? Okay, for a project, actually our human resources department takes in students, but because there are so many engineering colleges in Kerala and outside and all that, one criteria they have put is at least one of the candidates, 4 persons in a group, one of the candidates should be the daughter of a person in ISRO. Because ISRO people, otherwise what happens is the ISRO people's children are not getting in. So if you find somebody who's working in ISRO, you can join, you can give an application. And if there aren't any people, you can put in your application. If there aren't any people in which the employees' children are not there, then first come, first served. That way you will get a chance to do your internship in. Earlier, it was not like that. When I went there, I had no relatives. At that time, I just applied from the college and I just went there. And they used to take children like that. But at that time, the number of colleges in Kerala were very small, like 5 or 6 only. And people who were in Trivandrum only used to come. So at that time, anybody could join. But later on, number of colleges increased and so many students were trying to join. That is why these procedures have come into place. Yes. Will there be any solar research probe like Parker's solar probe in the future? Okay. Okay, one Aditya mission is there. It will not be like that, but they got 2 locations which will not be facing L1, L2 locations have been identified. That is done by our space physics laboratory, which will not feel the direct heat of the sun, but we can study a lot about the solar storms, the solar dust, and the other things by keeping those probes there. And that is yet to take place. Aditya is the mission. It is yet to happen. It will be happening in a couple of years. Then quantum technology has been applied to projects in yet or in the future. So far, no. But people are studying materials. People are on to that. A child from CSF personnel working in ISRO can join the internship. Yes, I think it is possible. You can contact the human resource development section. They'll be allowing because CSF working in ISRO. Definitely, I think it should be possible. Okay. How is space junk problem? Oh, yeah, that is what I call a debris. Debris is a topic by itself. There is a directorate as formed exclusively to address the debris problem. So whether how we can guide it and bring it into atmosphere and destroy it or avoid it, because like 10 minutes before the launch, we have a program, software program called COLA, Collision Avoidance Program. So that program is executed because it keeps track. It is an international program. It keeps track of all the debris that is available in the space so far. And then we study that the path which the launch vehicle has to take and the satellite has to be injected. Once they injected, then in that orbit there might not be any debris. So before that, we'll be facing the debris. So we'll see whether any debris is coming very close to that. So sometimes due to the debris coming near the trajectory is the path which the launch vehicle takes, we'll delay the launch by 10 minutes or 6 minutes, sometimes like that. That is the ritual. Like 30 minutes or 1 hour before the launch, we'll have this program run and to see whether any debris is coming. But debris management is a topic by itself. There are many strategies that is being worked on. There are international committees which are working on it. And there are many means of it. I cannot touch upon that now. But there is a program. Definitely people are aware and doing that. Then what is your take on increasing participation of private players in the space sector? Yeah, that is very much on. That is the new mantra. Because now we have so many people and our government is on for privatization. In fact, we have given codes and many people have come. I don't want to, it is public knowledge, but I don't want to say anything. There are many people who are working on like privately launching. There are two companies who I know itself. They have launched one set of people. Skyroot, I think you should have seen, and they have launched small, tested and done a small launch and all that, one stage and second stage to see how it works. So privatization is very much required because then only the cost of the launches will come down. And it has to be cost effective, means there should be competition. So let there be people doing it, because then I think ISRO can concentrate more on research. Because if you see, we are many launches, many satellites which we are launching are routine satellites which we keep on repetitively launching. So that can be given offloaded to the private players, and we can do more advanced R&D and technology studies. So that is very good. The private in Indian space sector is very good. Is there any specific season for launch to a debris collision, or is it mostly atmospheric? There is no specific season for debris avoidance, but we have specific season depending on the cyclone. Because I told you we launch it from our spaceport is from Sriharikota, which is near the Andhra Pradesh, now it is Telangana coast. And October to November, October middle to November end, we don't launch because cyclone, because there will be lightning and heavy thunderstorms and all that. But other than that, this avoidance of debris is only using that program, nothing else. We just, because we know the trajectory, and at that time, many of the debris which is flying around, whether anything will hit us or not, that will be studied by the program and identified. Because all the debris that is there will be identified by the satellites which are already in orbit. See, we get all the information from that. So from that only, the Scholar program also works, how it go, how at what speed it is coming and how it will hit us or not, or avoid it and all that. What will be the next ISRO mission, madam? That will be the PSLV one, because routinely we are giving PSLV launches. So that will be there. Any failure caused by
Caused by
debris?
debris
I
collision.
think we are locked on to debris. No, so far we have not had any failure caused by debris. No. Anything more? Is there? What is the
Is
question?
there any cluster of debris in space, like the garbage cluster in Pacific
Yeah,
Ocean?
it is there. I don't know why this obsession with this debris. Debris is there. There are clusters, there are area, but it is all studied and well documented. So there is no surprise element. So I don't think there has been any case where a launch vehicle by us or any other country has been destroyed by debris, and we have had a mishap because it is not. It is not like it is a surprise element coming up. Okay.
Yes, biotechnology and biochemical students have job opportunities in VSSC.
Biotechnology and bioinformatics, no, so far no. But why we are for the Gaganyaan that is going to play a major role because the effect of space, pressure, the temperature, etc. on the human body physiology. But we are using the help of the defense. They have a hospital there. So their doctors and scientists are help are being used. We have not recruited any people because we have to start from the beginning. So they have like the effect of zero G on the human being, zero G effect, and then temperature, pressure, and all those things, studies and all that to conduct that facilities are there, and there are facilities in Russia also. So whoever we are planning to fly in our Gaganyaan, those people have undergone training in both in the military hospital as well as abroad. But we don't use these people for biotechnology or bioinformatics. We are not using. We are not intake so
Oh,
far.
okay.
I don't know whether in future it will happen or not.
As you told, ma'am, all projects are being conducted in a cost-effective manner, and is it affecting the progress of the space research field?
No, but when I say it is cost effective, we study extensively the literature, what people have done. Like we compile a lot of things. I think if I have to go into details, lessons learned from our experience and lessons learned from other foreign countries. So whatever mistakes they have made, we learn from that. And then non-conformances which have come. Extensive literature study is done to see what all mistakes, what all could possibly go wrong. And we simulate as far as possible every scenario on the ground. In fact, for the Mars orbiter mission, see the liquid engine has to be shut off for 8 months, and after that, when it reaches the Mars orbit near the injection orbit where you want it has to be put on. So what we did is we put an actual engine in the ground in a similar condition and kept it off or something, then put it on and tested whether it works or not. And after that only it was used for the launch. Similarly, everything we study and whatever possible we can do, we simulate in the ground. Only suppose there are 100% functionality to be tested, all possible scenarios which can be tested in the ground and all possible scenarios which can be simulated on the ground is done before we launch it. That is the reason. And you simulate it, you don't not only simulate it, you analyze it also. Because when you simulate and see the results and you find an anomaly, you find a reason for that, and then only go ahead. So many people, what we have seen is many foreign countries do not do it because maybe they're not that much bothered about this thing. They do a skeletal this thing, amount of simulations, and with that they stop it. But we do for even 1 sigma, 2 sigma, 3 sigma, and up to 9 sigma. Like we know the propulsion cannot give a deviation beyond 3 sigma because it is designed for that only. But what we do is we test it so that to check whether our software has any bug or a problem, because ultimately the control, navigation guidance and control is done by software. So if there's an error, that only can go wrong because the mechanical systems or the electronic systems have been all tested. They also go undergo testing and the environmental testing and then extremes of temperature, the voltage, and all those things they go. So they have all tested and proven. So only if there's an unknown, because there's always you simulate thinking this is the way it behaves, but there is always an element of unknown. So that you put it as 6 sigma or 7 sigma and test it and find out whether it is working. So we do a lot of intense ground studies before we launch. That must be the reason it is cost effective.
Okay, ma'am. So I hope the question answer session is over, and I believe this talk session has inspired you all. And on behalf of EETI Foundation, I would like to express my sincere gratitude to Dr. Valza ma'am for sparing your valuable time with us. Thank you, ma'am, for such a enlightening session. And
Thank
big
you.
thanks to all the participants for the active participation and joining us today. So the feedback form is put at in the chat box, so you may fill it out. So thank you all.
Thank you. And I hope at least a few of you all will join ISRO because we need a lot of young blood. Okay. Thank you and bye.
Thank you.